Welcome everyone to the session on building an end-to-end data product using Python. For this session, as our speaker, we have Mr. Bargava Subramanian from Bangalore, India. Mr. Subramanian is a data scientist turned entrepreneur. His expertise is in building AI-first data products. He mentors students, individuals, and teams in their data science journey. He holds a master's degree in statistics from University of Maryland, College Park. It's time to invite him to the session. Hello, Mr. Subramanian. The platform is yours.
Hello, everyone.
Hello, everyone.
Okay,
Okay.
let's get started. For some reason, is this okay?
Is this okay? Is this okay? Is this okay? Is this okay? Is this okay?
Still not happening. Hi, everyone.
Hi, everyone. Hi, everyone. Hi, everyone.
Mr. Subramanian,
Hi, is this okay?
now it's fine. You can go ahead.
Hi, everyone. Fascinating that that we have some technical glitch, but okay, let's get started. A lot of the talk that you're probably going to hear today is going to talk about a specific topic in Python and then dig deeper into it. I thought maybe it's let's take a different take and then let's talk about the breadth of what Python can do, specifically to data scientists and data analysts in helping them build data products. Talk. So let me start. Let me know once my screen's visible. So I'm just going to check that my screen's visible. Okay. Okay, so that's what we're going to talk. How do we build an end-to-end data product using Python? Now, the context that we're going to use is cricket. Like more than 1 billion people in the world, cricket is a religion for me also. Right from my childhood, it doesn't matter if it's someone playing on the playground or if something is happening on the TV. I'm just glued onto it, just watching. The challenge is it just doesn't end there. It gets on into the living room, into the dining room, and we keep talking and thinking about it all the time. I always used to think, okay, fine, like what would have happened if something else had happened in this particular match? Like, why did this player play versus why did this player not play? What happens in this ground? So always was curious about, okay, we have all this data, very rich data that comes from watching the match, but then how do you translate that into some statistics? Pretty much all of what's there in the current web shows very basic statistics. So how many boundaries were hit, how many sixes were hit, but doesn't go deeper beyond something on the surface. The second thing is to see how I can use that statistics to think and then maybe engage with my friends, with my family, or sometimes just with me, right? Or with a community that's very interested in just discussing around a particular sport. So the context for what we're going to talk today is to see how, right from this idea, we can go and build an entire data product, which is predominantly more like a fan engagement portal where you can just slice and dice and see a whole bunch of things around the cricket data. That's what we're going to do. Let's build a data product in the next 30 to 45 minutes. Let's see what are the various components of it and how we can go and then make it. The specific Premier League, I'm not going to do a data analysis of Indian Premier League. This is more talking about what are the various building blocks that goes into building a data product and how we can use the various libraries that are available in Python to make that. Specifically, we'll talk about these 7 steps. How do we acquire the data? Once we get the data. How do we analyze the data? The analysis itself has different moving parts to it. So let's talk about the different moving parts that contribute to analyzing the data. The third is, okay, once we analyze the data, we need to present it to the user. In this case, it's me or fans like me. How do we visualize the data that can be done? The fourth thing is we need to make this repeatable. So we need to make this as an API. So how do we build an API? How do we package this in a web app? And then once a web app is done, as a developer, I want this to be in the hands of anyone else who wants to build on top of it. So how can we create a package around it? And also, how do we deploy it on the cloud so that there is a functional website? So that's all we're going to talk about. It might look like this like way too many things, but as I said, the context, this is more talking about the breadth of how it accomplishes, and it's pretty simple and intuitive to build it. So stay with me, and it's going to be pretty interesting what we're going to build. Okay, the first thing to acquire data, this is the common ways to build crawlers to go and do it. Python has some really strong frameworks to go and then build web scrapers. But here, luckily, there is a site that I found which has a collection of all of this data. This site is called ClickSheet. It has matches data. It has even ball by ball data. It's got really detailed data. So we can use this particular data to go and then build it. Some structure is it has got all the matches, and it's got data in JSON format. It's got data in YAML format. The one that luckily we're interested is in JSON. If it's really just web, then we probably should have written a scraper, but thankfully the data is available as a JSON. So here comes, so we need to find a way to read these JSON directly from this site into our application, which introduces the first library that we'll use. We'll use a library called pandas. Pandas is the most basic data analysis library in Python. And it has a function, an API called read.json, which directly can read from an URL. So it's pretty straightforward. You import pandas and you read the particular JSON. The basic building block of pandas is a data frame. So you have rows, you have columns, and you have rows, and you can do all sorts of manipulations around it. So you want to group by, you want to pivot, any kind of data analysis that you want to do. If you're familiar with something like Excel, then it provides you all the interoperability into building it using a very simple interface Python code. Pandas is your friend in doing it. So for an example, when we read this data, this is probably how it looks in the code, right? So there's going to be a data frame for a specific player, and it's got every single row can have a row label, and there are different columns, and it's going to stay as a data frame. Different way to think about this is just a table, but the nomenclature we use in Pandas is data frame. Okay, so what have we done so far right now is that we have identified a source on the web, and then we haven't written any complex scraper. It's directly reading from the particular source using Pandas. And this particular file is now saved locally on the disk, so on the specific laptop. So that's all that we have done so far, all right? The next step, once we have this data, is to go and then analyze the data. We want to see what kind of data exists, where there are challenges, and what we need to do. The first step to doing any sort of analysis is that you have to start with the questions. Like if you don't know what you're asking, then you're just figuring out needle in the haystack. So the first thing that you have to start doing is to go and figure out what are the various questions that I have to answer. So here, this is just me brainstorming with a couple more other of my friends, figuring out what is it that we want to do. 3 things that we came up with is, okay, let's figure out what are the various player statistics that's there, what are the various team statistics that we can put, and given a particular scenario, which is like something that we were always interested in, if you put someone in this particular scenario, who will win? So can we put a win prediction module into this? So 3 components to it. So this is where we're going to drive a lot of all of these analysis. Now, if you see, we got the JSON data from a particular site. It's got in a particular format. Almost invariably, that particular kind of format doesn't lend itself nicely to data analysis. You have a very messy data. I told you it's JSON, so probably it's very nested data, and you have to convert it into a very flat format so that you can build all of this analysis. So the goal is to, the first goal of the data analysis, the first step is to go from the messy data into a clean data process. Now, the framework, this is the framework that's typically done in any data analysis, data science project, is that you would take and then you would first refine the particular data. And when you tell refine, it has different components to it. So you could talk about, oh, there are all these missing values. How do I handle missing values? Maybe for a match like this, maybe it matters, maybe it doesn't matter. You have to drop it, or you have to replace it with some value, or you have to go and find a different source. You have to figure out how do you handle missing values. Because the value is encoded by or created in a different source, maybe there could be outliers that exist. So how do you handle outliers in those particular aspects? So some of these thinking goes behind in doing the data wrangling process. But once this is done, the next step is to figure out, of all the columns that's out there, what are the ones that matter? Because obviously when someone creates a site, it's something that there's a lot of data that's there, but we already have figured out that these are we're going to do only team and player analysis, and there's only a certain subset of the features, the columns that are useful for us. So how do we go and then build these, use these features? So we need to start doing some basic exploratory analysis around it. And then we have to go build models. So here we're not building any complex machine learning models. We're doing simple data analysis. So a model here is just a representation of what. So for example, can we summarize a particular view of a particular player? So that's it. And then this is an iterative approach, right? Because the data by itself, so for example, who has scored the maximum runs in the last 5 years? It changes from today to 3 months from now because it's a different time span. So you need to create all these features. You need to transform them at every runtime to make it applicable to the particular data problem. The fascinating thing is all of this can be done just using pandas. So it has various functions to fill missing values, to do basic exploratory analysis, to summarize the data. So you did the entire stuff using pandas. So, uh, so, so going from the previous step where we are right now is from the data we have now analyzed the data, and we have a clean data set that's now stored on the data set. And we have done a whole bunch of process around refining, exploring, creating some summary statistics, things that matter for our application, and then doing some bunch of transformations. So now that the clean data is done, we need to start building the right visualizations that can go and then present uh, for the application itself, right? So it's a whole bunch of things. So there's two broad ways in which you could do visualization in Python. I mean, this is in general. The most base library that exists in Python is called matplotlib. It's extremely verbose. It's run in an imperative way. You need to specify how the visualization needs to be done. You start with a blank canvas, literally a white screen, and then you take your data frame, you cycle through your entire data, and on the canvas, you're going to specify what's going to be on X, what's going to be on Y, and how it needs to look, what's the legend locations. You're going to give every single, you're literally going to construct your graph, your plot from scratch. The other way to do it, it's using this library called Altair, which is what we used for most of our plots. It's based on grammar of graphics, where so if you come from the world of Excel, it's a very different way of thinking. So it's not based on templates. Here you start with, okay, this is what I'm going to just tell what needs to be done. So for example, in the code here, all I'm going to tell is just plot like on x-axis plot runs, and on y-axis plot teams, and the color encode all of them every year has to have a very different color. That's it. And mark circle tells it this is a scatter plot. So that's all that needs to be told. And internally, the library understands how this needs to be constructed and then does it. So, so moving away from a template-based thinking to a more structured grammar way of thinking. So this allows us to create extremely complex and innovative ways of visualization, which generally isn't possible otherwise. Or it's at least not trivial to do it, right? So that's at least that's literally what we used. The other library that we used as we moved from Altair is that we need to, because a lot of these things we're using, the matches were played on specific grounds, home, away, and we want to understand how these things work. We need to use a geospatial library. The one that the most standard one in the world of JavaScript is leaflet.js. There's a Python wrapper for that particular library. It's called Folium, and we use it. The most fundamental building block that you have to specify there is GeoJSON. Tells that, so you're telling that, okay, this particular location from lat long is latitude longitude is a particular state, right? So that's what, for example, if you specify something like this is a state I live in, it's Karnataka, and then I live in Bangalore. So you would specify something, and you would encode it in a GeoJSON, and then you can start assigning values to it, and you can start visualizing it. Now that we have created the visuals, the next part is to go and then start creating APIs to figure out what needs to be done. The framework that we used for creating APIs is called Fast API. It's more recent compared to the other dominant ones, Django, which is a full web framework, and Flask, which is a micro framework. So Fast API sits in between Django and and Flask, and provides a lot of the flexibilities and ease of getting started like Flask, but has some of the more powerful features that's there in Django. So that's something that we used. One of the, it's really fast. It's really fast to develop. Just literally in 2-3 lines of code, you can get an API out, like what we had in the previous line. So you're just going to import. You're going to specify the app, and then this is the route that you're going to tell it. Or when someone calls, this is the API. This is the route that you're going to specify, and the function on what needs to happen when that function is called. Now, one of the biggest advantages of Fast API is that it creates a Swagger documentation, so that it creates API documents. So you know that you don't need to go and specifically write a different set of API documents. So it's out of the box in getting documentation, and it's extremely helpful as you collaboratively work in a distributed environment with different sets of teams with different skill sets. So maybe in front end, back end, different stuff. Okay, now that we have created the visuals, we have the APIs. The most challenging stuff right now is to see how can we build a web app, right? Because all this is fine, but if I'm going to put this in the hand of a particular user, we still need to have a web app in place. And that's the only way where it's easy to share and then make it. Luckily, there is a very awesome library called Streamlit, which allows us to create a web application, which predominantly makes use of a data-intensive web application in a very easy way. Literally, the script that we have written so far just got converted into a web app in less than a minute. That's it. Like, you install the library, and then you can run Streamlit run the script, and that's it. And the script allows you to do embed everything right from custom. So you can write custom text using Markdown. So it allows you to do basic formatting. It allows you to add visualizations that was built in Altair. You can call APIs that we built using Fast API, and it's easy to instantly deploy. Let's say this example, right? Like, how do we get started? So how does it even look like? So in a Python script, we import Streamlit, and then let's say that we give a text telling, hey, this is a title, right? And we save the script, we go to the terminal, and in the terminal, you're just going to run the particular app, and it immediately spins up in a few seconds. You have a URL. Here I'm just trying it locally. So you do it, and then the entire thing opens up on the web browser. That's it. But absolutely no necessity to learn front end. So you don't need to break your head to learn HTML, CSS, JavaScript. It's extremely easy to build a very functional data application, web application, just using Python, and literally 2 lines of code. Now, this is not the only thing that everything that we are going to see in pandas. So Streamlit also provides us with a few different options to filter, to select, right? So you can have different selection bar, like that's a list box. You can have different list boxes. You can have multi-select, have multiple items, and you can select like checkbox, and you can also have sliders to figure out what is it that you want to do. So for example, this is one of the screens from the application, which I'll show in a bit, that you can have a multi-select, and you can have multiple options for choosing here, and then you can have a slider that can go left to right. Now, okay, so that I mean, in some sense, that we went all the way from data, cleaning the data, analyzing, creating some of the visuals that we want, and packaging it as a web application. That's already done. Now there are two things that we need to go from that particular space to the next level. The first thing is it's not just for me, right? I mean, if I need to put this into every fan who wants to make use of it, or any developer who wants to add functionality to this, how do I make it in a way that is repeatable so that other people can use? So one, I want to ensure that I want to create a package. The second one we'll talk about is how do we do the deployment on a cloud machine. So how do we make a package? Again, there is a very easy, simple package called Poetry, which makes it extremely easy to do both packaging and dependency management for a particular Python project. So there are a few frameworks, but of all the things that we have tried, we found Poetry the easiest to get started and easiest to publish a package to pip, right? So that's the easiest thing to get started. So you just you're going to install, and then if you can run with the package that's out there, you can build it using Poetry Build, or if you want to put it to pip, you're just going to do a publish. So I mean, so it helps you create uh, your package files. So that's the thing. So let's take a step back and understand how the architecture itself finally looks like right now before we go into the deployment. So the data comes in, and we directly read the data using pandas. Some data analysis, a whole bunch of data analysis were done using, again, pandas. So we refined, explored, created some basic summary statistics and transformations. This particular output of this is a clean file that got saved onto the disk. Now, the two things that this output led to, one is creating a whole bunch of visualizations. And again, from that, some of these things required some custom APIs to be built. So one, creating visualization, creating APIs, and these two were again integrated into a web application using Streamlit, which again you saw is a few lines of code. And this entire thing, just to make it repeatable, a package was created using Poetry. So just using pandas, altair, folium, fast API, Streamlit, and Streamlit, the web application is done, and then one package to build and create a package. The last step in the process is, okay, now that we have all of this, I want to create a website and I want to go and then put it out there. What do I do? So it's pretty easy. We deployed this on Google Cloud platform. It's pretty easy to do. We logged into Google Cloud, and we can do this in Heroku, we can do it in DigitalOcean, AWS, doesn't matter. The process is all the same. You're just going to go, we log into the shell, and you're going to do pip install IPL stats, because this is, if you see using Poetry, we published this as a package to pip. So now you can directly do pip install IPL stats. And you write a script which tells us from IPL stats, imports, or run server is a module within the package, and then you're going to just call it. This module is the Streamlit module. It's just going to invoke and run the Streamlit application. And when you have something like this, this is the screen that comes. You're going to have the default view that comes in, and you have an entire application that's out there. So now, once at your package, you're just going to install the package, and that's it. The web, like literally, that's it. Like you have a script, and then your web application is up. It just makes the process extremely seamless and easy to get started. I want to use this time to show. I mean, this is like literally a site we brought it up yesterday to do it. So when you launch, this is entirely built using Streamlit application. So you can see that this is the stuff. I can go and then see, for example, I can do Virat Kohli. He's like captain of the city where I am, RCB. So I can see what his performance over the years has been. There's like a lot more data, or maybe I can come and then if I want to do team selection, let's figure out lucky winners. We wanted to see how I'm going to pick. Hopefully I have Bangalore here, and then I can see how the application. Well, it's loading. So it's this is the one that's going to construct the GeoJSON, and it's going to show. Well, I think you can clearly see we have a lot more work on improving how the visualization itself should work, but for some reason this is like a different team. But anyway, so this is something that will show you how the application itself. It goes, it does the analysis, and it renders on the screen telling, okay, these are the various teams, and this is how the win probability in the various regions are, right? So, and I think you can go, and then this is like what we were seeing before. Like, I want to see overall stats. It has all these. It's pretty responsive. It's really easy to do. And you can see that, I can play around with my sliders. I can select all the columns that I want. So it does. So you can see that as I do these selections, the filtering happens easily. So that's in terms of the application. The code itself is available over here. This is the entire code that's out there. This is like Poetry provides, it scaffolds your entire structure. So it's really easy. It allows you to, I mean, if you want to add tests, you can do tests, and then there's a whole bunch around, like literally. So if you, this is what we're going to call. If you see, we were calling run server. The run server had a streamlit application. That's it. So it's going to call app.py. And if you go into app.py, it's going to do a whole bunch of how your web application itself should look like. So it's going to give you the UI for it, and then each one of those components you're going to just call. So that's pretty much what is happening here. Want to take this time to thank both my team, Naveen and Ashwini, who helped me a lot in building this application out. Huge shout out to both of them. I'm hoping they're listening to this talk from somewhere. As I showed, the code is available on GitHub, and you can you can do a pip install. Please feel free to give pull request, or please use this as an inspiration to build your own data products. We literally pulled this off over a weekend. So all that we did over last weekend was do this, right? Get data, do this analysis, and then create a website. So it's pretty possible. And none of us are front-end engineers. All of us know only Python. So it just made it easy to come, play around, and then create an entire web application. So that's the power of what we can literally build using Python. I'll take a pause here. That's all the slides that I have for today. Thank you so much. I'd love to answer any questions that you have for me. I mean, you can either come to the screen and talk, or you can post a question here. I'm very happy to answer any question. Yeah, I can't hear you, Ashini, for some reason. That's so Taranga's made a point telling Streamlit seems to be a good catch, must have saved you a whole lot of work. I mean, so I've built a whole lot of web application. Just the power of converting your idea into reality has always been a challenge for someone who comes from the Python world. So even if you've ever tried even building applications using Flask Django, the thing is you still have to write the HTML and CSS, and that is generally, I mean, like I need to go and then figure out something new. It's always been a huge challenge. Just having some of these things in Streamlit coming out of the box save tons of times. That and Altair, so I don't need to go and construct it. So thinking from a grammar graphics way enabled us to create extremely beautiful visualizations. What advice would you give okay, so question is, what advice would you give an undergrad interested in a career in data science? So I would say that the most important thing is build your portfolio really well, right? Now, don't pick one of those. I mean, when you start, it's easy to use a data set that's already out there and then start doing it. But if you're not interested, you will not get very far. The way to do it is, for example, I just showed you an example of literally scratching our own itch today. Like we were like, okay, 3 cricket fans, we are figuring out like, okay, what do we give a talk in PyCon Sri Lanka this year, right? So, and then we're like, okay, we all love cricket, and Sri Lanka is a very cricket crazy country like India. So I was like, okay, fine, there is some synergy that we can use, and then we can go and then do. So build, and like, this is like literally truly differentiated, and did this over a weekend. So you know that you can start creating this kind of portfolio where you can start doing one. The second thing is start understanding the process, right? So if you see what I started with, understanding, start with a question. So understand what question that you need to do, and then start going from the question that you want to answer. So I want to understand player and team statistics in IPL. It's a question. So how do I break it down? How do I get data? How do I clean? So understand this process a few times. That'll give you a lot of edge in when you go and then start building a professional career in data science. I mean, even industry, even people like data. I mean, even so, one thing to think about is now every role requires data. Like you can be a hardcore software engineer, but you go and check, okay, is my build happening fine? How long does it take time? There is data in every single activity that we do. So having this understanding, how do I represent and how do I communicate, is such a powerful skill set to have. Okay, I think someone asked what is end-to-end in data science, right? Okay, this is okay. So this is how I think about end-to-end, right? So you have to start from problem. Like what is a problem? How are you structuring it? It's called framing the problem, right? From framing the problem to like the audience that who is your audience that you're going to specifically talk to, how you're going to start taking it, and then start placing it in the entire process. So you're cleaning, refining, data wrangling, data munging, all the things that happens, creating, putting it into, so for me, I use the data file, but you can put it into a data warehouse, which is probably what people do in an industry, and then build these models. The models could be statistical models or simple summary statistics like I did, or it could be machine learning models. So know how to do APIs. So how can you represent the data? So that's visualization. How can you put them as a repeatable aspect? So that's APIs. So that's what constitutes an end-to-end for me. So right from framing the problem to communicating to your stakeholders. So do you understand that entire stack really well? There's a question, what is better, reading data from files or databases, right? So that's, well, that totally depends on how your data itself is, right? In most industry setting, you would probably, the data is probably already in some database and you just have to take it from a data. Most of the times when you are building your portfolio, you're going to take a data that's in CSV. There is no right or wrong answer. It purely depends on the problem that you're working on. And Python is really good. You don't need to learn a lot of database internals to make things work. There are easy connectors for you to do. Basic knowledge of SQL is good. What's the difference between a data scientist versus a data analyst. You're like opening a Pandora's box. I'm going to answer something and I'm going to be ripped apart for telling this. Okay, so there are different ways of how you think about. So let's think about, well, all of these terms are very, very overloaded terms. It means that different companies use these terms in very different ways. But for you to think about what a different way to think about is, like I am in the data space, data science, data analyst term doesn't matter, but what different roles exist. So two dominant roles, two different kinds of roles exist. One kind of role works with business stakeholders. They are business facing. So they would be reporting, say, to the CEO or a VP or a director. And most of the work would be bespoke. It means that it's going to be custom work that's going to come. Okay, tell me, why did sales for Q4 20% lower than sales for the previous Q4? Like, why was the sales down? So the questions will be something like this. The CEO has to go and give a talk, and then they would have this question. They'll be looking into this and the work of this particular data scientist, data analyst. So this is typically what a data analyst would do, would be like to go figure out, understand. So there is a lot more knowledge of domain. A lot of what is being done would be within the realm of pandas and visualization. So they would make this, and then the output typically goes in an Excel or PowerPoint. Data scientist works on the other end of the spectrum, where they're tightly embedded with the engineering organization. So they would be building things like, okay, like things that can be entirely automated, right? So think about, okay, I watch, say, Netflix or YouTube, all the recommendation system that comes in. When a user clicks, these are the 5 different recommendations that need to come. So you need to build real-time recommendation systems. You cannot take a week to build something like this, right? So you need to have something which is an automated process in place. So when you have, so this is one. Or the second thing is, like I get this call all the time. When I make a transaction on my credit card, immediately within 30 seconds, I'll get a call from my bank telling, sir, did you make this transaction, right? So this is like fraud detection, to know that is this normal, or if it happens out of the normal, then is it identifying a fraud detection. So when the data is responsible for making these models have to scale. These models probably involve a lot more machine learning code. That's typically how a bunch of data scientists do. But as things are getting commoditized, there are few more things that are coming in the data stack, and that's probably what I would say are set of things that machine learning model. So, I mean, okay, I want to build some predictive model, right? So to tell that, okay, given the current state of the match, will the particular team win or not? What is the win probability of the particular team? We even have a module there telling if the team will win given a particular situation. That requires a set of computation based on the current state. So that lends itself nicely to a predictive model. So it makes sense from an architecture perspective to call an API to do it. Streamlit is a web application. So if I do like the site that we did with iplnanny.com, if I need to do something like this, I need to have a web application. The typical process to build a web application generally before the world of is to go write HTML, CSS, JavaScript, that's your front end, and then you will do your back end in Python, which is only API, and then you from the front end probably use React or something you will call. That makes it, so now you have this two language problem, which is very hard as a developer creator to learn and be good at both the things. All Streamlit allows me is to tell, I mean, I'm not telling it's going to be as flexible as something like what you can custom build in JavaScript, but clearly I can go a very long way with just using what's available in Streamlit to go from an idea to my first prototype. Say I want to build my own startup, I want to scratch my own itch by building some analytics around Cricut. These are very simple, these are things which doesn't require me to go and learn an entire new web framework. I can just do it in Python and I can get really good results. So that's what Streamlit excels in. So Streamlit, think of it like a replacement for HTML, CSS, JavaScript. It's absolutely not as powerful as them, but it'll help you get started going from idea to implementation. Fast API, on the other hand, is how you think about structuring your code base itself. I want all of this to be modularized so that I can write APIs for them. How do I analyze real-time data such as IoT data is the next question. So so when you have real-time data that comes in, the process is still the same. So this is not a challenge with the process. You're going to have some question. Okay, so let's say an example of IoT data. This is a complex manufacturing plant where there's a whole bunch of operations that's happening. If the temperature, say this is like steel rolling or something like that. If the temperature drops, say it needs to be ideally between say 1000 degrees Celsius to 1100 degrees Celsius. And if you consider a drop, then you need to notify. The challenge is not in the data science process. This is more a data engineering task. So you will need to build a lot more data engineering pipeline on how to get the data. So you are probably going to look into the IoT, you're probably going to use MQTT, or you're going to use something like Kafka to do it. So that's all outside what you would do from a pure data science or data analysis perspective. It's mostly from a data engineering perspective of how you get the data which is there in the particular system into where you're doing your processing. So that's where you're going to start doing. Okay, somebody opened another huge question. Is it a good practice to use multiprocessing to improve performance in data analysis? Okay, so this is a talk on its own. Okay, so but I'll tell you, Python allows, so there are different libraries to do it. One is, as you told, there's a multiprocessing module, but even beyond it. So let's think about, so we are using pandas, which is on the bottom left quadrant. So if you think about 4 quadrants, it's on the bottom left. You can either scale up or scale out. Scale up means that I go from 4 GB machine to a 16 GB machine to a 32 GB RAM. And I can go from an i5 processor to an i7 processor to whatever your 16 core machine. So I can improve my cores, I can improve my memory. That same box I can keep increasing. That is called scale up. Scale out tells that I can go from one machine to I can build 10 different machines. So this is cluster computing, right? Distributed computing. I can go from one machine to multiple machines, and I can build processing around it. Now, Python has packages to do both of it, right? So, so you can the drop-in replacement as you go from pandas to going to all these things matter only if you're going to do like extremely large amounts of data. So, so Dask is what I would suggest because it has a very similar API interface like Pandas. So Dask is one way to do. A lot more on the industry side would use Spark, PySpark, which uses which is built on JVMs. Initially came in Scala, and then there's a Python interface in PySpark. But that's something that I would probably recommend Dask over it. And increasingly, a lot of this kind of distributed computing is using a file format called Arrow. So it allows you to do a lot more stuff, and maybe using GPU. So there are accelerations on Pandas using a framework called Ray. So you can go and read about it. So all these things matter only if you're going to deal with lots of data. Even for the kind of data that we did, where we had to do a lot of this processing, it's literally not GBs of data. So for most common practices, you would never really see. It's mostly the first step of the process where you acquire the data that you're going to spend a lot more time. The number of cases, if you're really going to be working in extremely large data where these things matter, then there are obviously libraries like PySpark, Modin, things that's built on Ray, that'll help you. Dask, of course, everything that, so NVIDIA has a whole bunch of libraries around the Rapids framework, RAPIDS. There's a whole, that's an entire suite of products that works on large-scale distributed real-time processing. It's all open source. That's all like the right and top end of the spectrum, right? So, okay. Okay, can you please share the tech stack you used here for the reference? I think I had a deck, I'll post my slides too, but literally we used pandas pretty much for all of it, right? From getting data to data analysis to refining data, exploring, all of it we did. The visualization was built using Altair. The web application was done using Streamlit. The packaging was done using Poetry. And the APIs were done using Fast API. So literally 5 libraries, and folium for JSON. So 6 libraries for the entire application. That's it. So all entirely done only using Python. So no custom HTML, CSS, or nothing else. It's entirely built just using Python. The question is, I use Jupyter Notebook to train and export the machine learning model. Then I'll use VS Code to develop the web app. Can you suggest any alternatives to use this tool? Will you experience any issues? So that's, I mean, interestingly, that's my workflow too. So, the notebook, I mean, I should have shown Jupyter Notebook today. I'm sorry. It's a very simple IDE where you write code and then you execute it and the output is there. It's just on the browser. Jupyter Notebook, the way of writing is called literate programming. Literate programming is a way where the code, its output, and our thought process, which is the documentation around it, are all captured in the same sequential way. So that when we come, it's mostly for our future us, that when we come back, we know why we did something like that and what was the result and how did we go about doing it. Now, when you want to operationalize it, now there are tools like there are SaaS companies like DeepNote, which makes it easy to deploy a notebook itself. But the most common methodology is what Turka tells, that we'll download the script, import it into VS Code, refactor it, modularize it, and then create it as a package. That's typically my workflow too. That I take the data. It's easy to analyze on Jupyter Notebook, but if we want to make it like, say, the package that happens, we would use a tool like VS Code. Amila has a question: how to handle categorical missing values? Okay, the most common way. So think about it, right? So in a categorical column, say I have take any specific category, right? So grades is a category, grade A, grade B, grade C, and then some grades are missing. Now, missing can be a category by itself. That's the easiest way to handle. Like, a common way to do it is to use just the common things to do. The second one to do is to use mode. So mean, median, mode. So mean and median don't make sense for categorical variables. Mode is number of times the maximum occurrence of a particular column to go and then do it. So these are 2 common ways in which you would handle missing values. A lot of times missing values itself as a category is typically how it's handled in a number of machine learning applications. Okay, I think I'm done with the number of questions. Thanks, everyone. Yeah, thanks, everyone.
Heartfelt gratitude to Mr. Subramanian The links for reservations are posted